A humbling experience for you all to listen to what I have to say. But nevertheless, my presentation is actually, it has a different name. It's called 1 BPS. And I'll explain to you what, I mean, we are used to saying, so many megabytes per second or gigabytes per second for our internet. But I'm going to talk about 1 BPS. And we just, come to what that means. First slide, please. Okay, so this says that 1 bit per person per second. That is, what if your internet trickles down to just providing 1 bit per person per second, and what can be done with that? Just move this.
Yeah, you can use one of the screen as your background.
Yeah.
That's it.
So just to give you a perspective of our telecom network now, okay, okay, let me say this, that the biggest machine ever created by mankind, what do you think is it? Is it a dam? Is it the railway network? Is it, the space industry? The biggest network that human beings have created is actually the telecom network. Nothing exceeds the scale and the grandeur of the telecom network. So if you took the fiber which is being manufactured and deployed across the world and laid end to end, it will span the solar system. Next slide, please. So that's it. I mean, it will go from one end of the Kuiper belt to the other. It's that huge. There's nothing that we have created which is as big as the telecom network. And it turns over $2 trillion every year. $2 trillion, right? So I did this calculation of how far will $2 trillion take you. Now, if you have seen these three-wheelers which have been jutting around Hyderabad, which are called scooters or rickshaws or tuk-tuk or whatever you have, and you pay a rickshaw $2 trillion, where will it take you? Next slide, please. It will take you all the way to Alpha Century. Okay, that's as far as it can go. So it's a lot of money. I mean, we have no idea of the magnitude of this money. Okay, it's $1 million, $1 million times $1 million. So, given that it's such a huge machine and it's got this breadth in it and magnitude, still, it's not accessible by all. And why is that so? Next slide, please. It's essentially because it's completely unstructured. Okay, this is a shot from Hyderabad actually. This is how the gigabit network in Hyderabad works with OFC cables. It's unstructured, it's not level field, it's got all kinds of barriers, it's got all kinds of narrating with it. It's a mess, it's really a huge mess. And this mess doesn't just extend to the low-income countries, the so-called underdeveloped world, as the developed world calls us, etc. Next slide, please. So if you see, let's say, look at just the internet spread of India, okay, you'll see that it's very bad. So here the tele-density is the lowest, which is a large part of India, mostly the northern parts of India. Some parts, including Telangana, have a better access to it, but you'll see that even there, the access is not so good, right? And if you see the amount of mobile internet users as opposed to mobile users, they are far lower. For example, in Bihar, you'll see that 34 million people have mobile phones, but only 7.4 million people have got internet. So the internet and mobile phones are not matching at all. Okay, there's a huge problem here. And similarly, if you see the percentage of households which are having computers or laptops with internet connection, they're really, really low. Really low. You can see that. That basically is Telangana, 0.07%, only 0.07% of that. And you think that, all right, India is underdeveloped, if we make some policy interventions, things can get better. Next slide, please. If you look at the United States, the situation is equally bad. Now, a large part of them, if you see, which have broadband access, the white ones are where there's no significant broadband access at all. So, how do we level this? Is the question, right? What does it take to level such that people have access to basic facilities which are provided now only on the internet? For example, banking, right? For example, just being able to send each other a message. So what we have to figure out first is what is the practical minimum? What's the minimum amount of internet that a person requires? And then see how it can be delivered. We all cannot be doing Netflixes. We all cannot be doing YouTubes. But there are certain services which can still be provided at a lower bandwidth. And we have to get that to that point first. Next slide, please. So the other problem also is that of global internet shutdowns. You will see some unfortunate cases here, which is India itself. But we've been looking at these shutdowns, which are either due to the government actions or just due to something else. For example, in Sri Lanka, a ship dropped anchor on a fiber optic and then it's completely shut out from the internet for a long time. Next slide, please. So now, how do we get there? How do we provide everybody in the world, let's say, access to some minimum amount of data connectivity? And what is that data connectivity? Then we'll go on to how it can be provided. Next slide, please. So the practical minimum, if you look at, what is the minimum capacity to sustain, let's say, there's a community of 1,000 people, and there are some messages which they are exchanging between themselves and some messages from outside the community to inside the community. So I'm looking at about 20 messages a day. Okay, 20 messages. Just text messages between people. I'm looking at about 5 transactions. That is 5 things that you can buy or transact to the bank. 3 emails. Maybe 5 emails with attachments and 5 local calls. Now, if you look at the data which is required to do this, next slide please. It's about 10,000 bytes of data in 24 hours. That's all you require, 10 kilobytes. It's the size of one heavy, graphics page. For example, if you go to CNN.com, that itself is about 100 kilobytes, one single page. But what you require here is actually far less. It's just 1 bit per second. So 10,000 bytes in 24 hours is 1 bit per second. So this is what we have to promise to everyone, which is how do we deliver 1 bit per person per day? Okay. 1 bit per person per second. That's all our requirement is. So we have to get that. Now there's a whole bunch of technologies which is there in that comm vehicle which you see out here, which have been developed completely in open source by many of these people that I represent here today, and I'm going to talk about them individually. Next slide, please. So these are the organizations which have been involved here. There is, you already know some of them. That is the Digital Empowerment Foundation. And I will explain the others, and I'll actually explain this in the context of ARDC. Now, ARDC, for many of you, and I'd like to introduce ARDC, and I'm a board member of ARDC, stands for Amateur Radio Digital Communications. It's a $150 million grant foundation, which gives grants to all people who are working at providing digital connectivity in less served areas, and especially if they have a focus towards amateur radio, but that's not required. For example, if you like to create a Wi-Fi network in your own village or town, they're the people to approach. The only thing is you need to have an equivalent of the US 501c or FCRA as it's called in India. You need to be a non-profit. You need to be a non-profit recognized by the US laws. But that's so under them. A lot of projects have happened. One is with Hamnet.eu, I talked about that, and the other is Osmocom. And what you see here, HF Signals is a company that I run which makes open source wireless sets. I'll talk to you about that. And Namakan MH Radio Club is a club here, which is a technology club where more technologies are developed, and we'll talk about that. Next slide, please. So what you see here is actually a map of Europe. Okay, and each of these black pins that you see is actually a Wi-Fi network with a long-range connectivity of about 50 kilometers each. So this is a network which has been created by non-profits across Europe, okay, all the way from Spain up to Norway, which works independently of all the commercial telecom networks in the world. Okay, so you can actually send messages, you can browse the net, you can do everything that you want to do. From this, you can go to hamnet.eu and you will be able to, what happened? And see this map. And you can actually keep adding more to it. And if you see what's happening here is that these links are basically interconnecting all of them at 50 Mbps. So there's 50 Mbps of bandwidth available across all these places. It started in Germany, it's spread to everywhere. They are now actually trying to get it across to Canterbury and get into Europe. The entire technology for this, especially when it came to fixing the Wi-Fi for long range. Now, Wi-Fi is crippled. Whenever you send out a packet, right, it travels at the speed of light, it hits the next Wi-Fi client, and the client has to respond back. Now, if it does not respond back in time, it thinks that the packet is lost, so the connection is not made. Now, this timing is such that you cannot hope for this Wi-Fi packet to travel more than 300 meters, which is why Wi-Fi doesn't work. It's not that the technology is not there. It's been crippled on purpose. So we hacked it such that this could work. So that's one of the components of the solution. Next slide, please. Now this is what has been developed at HF Signals. This is a high frequency radio. And what's special about it is, as you can see, it's very small. And what you see here are the messages that it's receiving from across the world. So HF, or high frequency communications, are communications that work without any telecom infrastructure. Okay, they just bounce signals off the ionosphere. It's a little like the shortwave radios. I mean, we all grew up listening to Voice of America, BBC, etc. Right? They all work on shortwaves. Shortwaves are not being used anymore, but this one repurposes shortwaves for long distance communications. I mean, on an average, about 5,000 kilometers can be done. The converse is it cannot do high speed internet. You can send only short text messages, but that's one. Next slide, please. Now this is a network of a GSM base station, of a GSM network, right? So this is your mobile set. It connects to GSM tower. It goes to what is called as the radio network controller, and then it goes to a lot of other stuff, right? But this entire thing is called the core network or the switch. Now, in order to deploy this, just in terms of technology costs almost $100 million. Okay, because of all the equipment required, the IP, etc., etc. So ARDC actually put money behind this organization called Osmocom, which is essentially a bunch of hackers, to rebuild the GSM network entirely in open source software. And the result is this. Next slide, please. So what you see here is a Raspberry Pi connected to a very small interface, which interfaces with the wireless. This stuff is available here. It's a complete GSM network. It will allow you to register onto this network. It will allow you to get your own, phone number immediately, and then you'll be able to talk to each other on this network. What's the price of this? The entire thing put together will be less than $10,000, as opposed to $100 million. So this is what we hope that a combination of all these things together can be packaged as one unit which can be driven or even hand carried into areas where you can instantly deploy digital connectivity. Next slide, please. Now, this is the last part of this leg, which is basically based on satellite communications, and these are right now, they're not talking to my satellite, which is a lower orbit satellite, but a geostationary satellite built by by Radio Hansen Qatar, and in Germany, it's called Q100, which provides a fair amount of bandwidth, and these are actually repurposed television dishes, which you use for television stuff. You can see, probably you can't see it because of the high buildings here, the visibility is not there to the satellite, but I can assure you that this provides up to 2 Mbps connectivity. So we put all this thing together, package them into one box. Next slide, please. So this is what the control station looks like. It looks like it's a spacecraft, but actually, believe me, you just switch it on and it works on its own. You don't really have to sit and keep monitoring all the time. And we've packaged this into one van now, just to demonstrate to you people. Next slide, please. So that's the van that you'll see here outside in T-Works.